Hello everyone, thanks for joining. We have Jonathan from Beam Dental today. He will be going through React abstraction patterns and React hooks. Thank you for joining the meetup today. And let's get started, Jonathan. I will stop the share and give it over to you.
All right. All right, so today I'm going to be talking, I'm Jonathan Narwold. Not sure how many people we have here today. Were we doing a little bit of a meet and greet or?
Yeah, like we usually have the initial 5 minutes to have people get introduced who are on Zoom.
Anybody else here that would like to introduce themselves?
So I see like 2 of them joined through Zoom today.
Okay. All right. Well, maybe we'll have some more later on.
Yeah.
I'll just launch into it here. My name is Jonathan Narwold, and I, as Bhaskar said, I'm a senior software engineer at Beam Dental. So who am I? I grew up in the suburbs of Milwaukee, the Milwaukee area, Wisconsin. I've lived in the Columbus area for 6 years. I have converted to be a OSU fan. Looking forward to seeing how far they get this year. I am also a lifelong Packer fan. I know nobody's perfect, but a lot of people, when I tell them that around here, they say, I don't blame you. So definitely sympathetic with all the Browns and Bengals fans around here. In any case, I was a tech enthusiast from a young age. Got into tech very early. I remember my parents' 286 machine in their basement, green screen or orange screen or something like that. I can't remember which. And I'm the father of three little ones, 2 girls and 1 boy, pictured here. And my joke is that I had hobbies and now I have kids, and they're my hobbies. I enjoy spending time with them. On a professional note, before I get to that, I'm going to see again who's on the line here, and if anybody's there and would like to join this. I have a couple live polling questions. So go to the website and put in the code, and in just a second I will ask those. But to continue, on the professional side, I've been developing websites since my teen years, did a lot of work with PHP frameworks in the past, WordPress, but I also enjoyed more complex apps, some of the PHP, like I said, more enterprise type PHP frameworks. My JavaScript knowledge really took off when I co-founded a startup called Quiet Time and worked there for 5 years. We were an IoT company that put sensors into hospitals, hotels, and apartment buildings to measure sound levels, temperature, and humidity. And we did that because for a variety of reasons, depending on the market, but the hospitals in particular stood to gain or lose funding on the basis of whether their patients got a good night's sleep. So we would monitor the environment, not record anything because that would have been a privacy nightmare, but basically just record sound levels so that they could determine some of their problem spots. And so I was responsible for the entire tech stack, which consisted of Raspberry Pis at each location, collecting data, a remote server that collected the data from each of the Pis and processed it, and then our React-driven website, which used WebSockets to stream incoming data to the end user. And as an interesting side note, we had started a cutover to an all GraphQL-driven website with Apollo Link to stream query updates. So you would basically subscribe to, or you would make an initial query over GraphQL, and then at the same time, you would be automatically subscribing to updates that came through WebSockets. So that was a pretty cool project. Since then, I worked briefly at 90 Degree Labs, which was Wendy's innovation lab, and now I work for Beam Dental, a dental benefits company in Columbus. Brief plug for Beam, if you ever think about working someplace locally here as a developer, the Beam team is doing a lot of things right. We're an Agile shop that, from my perspective, really embraces a lot of the important aspects of Agile. There's plenty of room to grow and get involved in fun technologies, so check us out. So I'd like to learn a little bit about who's here and see if, so first of all, what front-end technologies have you developed in? All right, so we got some heavy React use, and we got some jQuery. That's to be expected, and some lesser known Vue or Svelte. That's interesting to me as well, because those are ones that I'm not super familiar with, but I'd like to get into more. All right, so next question is so a lot of React. Next question is for the React devs, which have you used in the past? All right, so a little bit of Mixins. We got render props, which is a little higher than I expected, so that's good. We've got some exposure to different things here. All right, I'll give that a little bit longer. And switch back over here. All right. So today we're going to learn a little bit about that history. What were the strengths and weaknesses of each? So this is really a history of the ways that React developers have abstracted their code into more generic building blocks that are either non-app specific at the library level or span the needs of multiple parts of your app. So my assumption going in is that most people know why separating these chunks out of your code is important, but we'll briefly touch on good practices like DRY, the do not repeat yourself, and single responsibility principle, and so on. And there's some other ones, but I'm just glossing over this whole subject area. So I assume that I'm not isolated in this, and that this is common, but my typical workflow is when I start working with a component or design a piece of code, I'll kind of pay attention to the size of that. And you know, there's other ways to tell this, but in particular, if something starts getting arbitrarily too big, and I say arbitrarily because it can vary depending on what you're putting in it, but that could be anywhere from, you know, more than half a dozen lines of code to more than 100 or 200, depending on, again, what it is. But once it starts getting very large, I start thinking, is there a subset, is there a logical unit within this component that could be pulled out and thought of as a separate piece? And I think that that's an important thing to do, whether or not you're elevating something to the library level, even if you're just co-locating it with your component. So we'll break down a real world example of that later on. I'm also assuming that many of you are already familiar with the history I'm going to be talking about here, and you're asking yourself, why should we care, especially about Mixins? Aren't those ancient history? Well, that's true. But as a good friend at work has been good at pointing out to me recently, he'll go back and pull very obscure technologies that he's been familiar with from 10 years ago or however long ago it is. And he'll point out that a lot of these things have been tried before. And so there's lessons that we can learn from what's been tried before and succeeded or failed, and how we can do it better, or how we can learn from the past. So we'll start with Mixins. What are they? They are objects that earlier in React's version history allowed you to mix functionality into your React components. Their motivations were admirable. They attempted to apply some of these principles that we just talked about. But there were some shortcomings that we'll address in a moment. But first, for an example, so this is just a random, maybe not particularly useful mix-in, although it could be. But this is called click away. So if I click the component, then it says thanks for paying attention to me. If I click away, then it says to come back. So this is how you would apply a mix-in. You would put it into an array of mix-ins. And essentially, the create React class, this is not something we do anymore in React, but this was the legacy way of, it actually looked a little different back in the day. It was React.create class, I believe. And that allowed you to create a React component. And then within that component's namespace, the mix-in would essentially mix functionality in. And then this is a method that is accessed by the mix-in. We'll talk about, well, I put a comment down here. How do I know where this came from? How do I know that this has anything to do with that mix-in? That's my first observation. So this reacts to when I click away from the component, and it sets some state. So what could go wrong? And I wanted to open this up in case anybody, again, I'm not sure what platforms we have here and who can talk, but in case anybody has any thoughts on this or any experiences with this, I'll give you a few seconds and then I'll answer the question. All right. Feel free to pipe up later on. I'll have a couple more spots for this, but I'll go ahead and answer. So mix-ins were tightly coupled with the components, like I said, because you mixed into that shared component namespace. There were a lot of things that could go wrong. Too many things were sharing the same scope. There were no clear boundaries with carefully documented APIs or signatures. There were implicit dependencies. You didn't know when renaming something in one mix-in would cause an issue in your component. And you also didn't know whether two mix-ins could be used together because of potential for name clashes without knowing it, because a lot of those names were hidden inside the mix-in. So as a result, you had snowballing complexity. And most importantly, next slide. This is an example of what the mix-in looks like. So this is my click away mix-in that I showed a second ago. And the first thing I want to point out is there was already an on click away that we used in our component. But there's also this other thing attaching to the component called click away. That's an event listener that's attached to the click event here. And we don't, without delving into the code of this mix-in, we don't even know that this is here. So again, we could have some name clashes. We would never even know it. So that's something to point out. And then this is something that is triggered within the component, but we don't know that it's here unless it's carefully documented. So I had a graphic. Oh, there we go. So the React team deemed mix-ins dangerous and said, get rid of them. So that was that. So the next, after people kind of reacted to that decision to deprecate mix-ins and we're trying to figure out what to do next, someone came up with the idea of HOCs, higher order components. And I'll see if anybody has any contributions here. What are they? All right, at some point here, I'll stop asking. Okay, so according to the React docs, they were a advanced technique in React for reusing component logic. So this was pretty much a way to inject anything, props, context, lifecycle, etc., into the React component tree. It's often used for API abstractions, state management, browser abstractions, and so on. We'll talk about this a little bit later as far as what purpose a lot of these things serve, but it's basically a React-specific construct that allows us to hook into React features like I said, state management, API, and side effects, and so on. So here's an example of that. I've created a demo component. I have a with hover HOC that I'm attaching to it. And because I've wrapped this underlying component in with hover, I get some props that come out the other end. So I have hover props and I have is hovering. And the hover props go on a DOM element that waits for you to hover over it. So when I go over there, it says, good to see you. And then the is hovering it's actually maintaining some state internally inside that wrapper. All right, so then we have the HOC itself, and this is the wrapper. It's taking in the component that it's going to wrap, which is the inner component, and it's returning a new component that wraps that original component. Now, I'm going to seed my next slide a little bit because one of the first issues that you have here is the naming issue. So when you return this, there's not two but one component that gets returned, and your component, if you're debugging this in the React DevTools, now becomes the name of it becomes wrapped with hover, and this caused some issues because you're looking at your React DevTools and you have half a dozen different types of components that all have this name, and that can cause some debugging problems. So here it's rendering as part of the render for the wrapper, it's rendering the inner component and it's attaching some things to it. All right, so HOCs had some advantages to them. They maintained the component boundary better than Mixins did. They did not mix into the component itself. Instead they put a wrapper around it. So there was no more name clashing within the component namespace itself within that class, and they were a little bit more functional. The output of one would be received by the next, but there were some issues. In my experience, now the key to this is how many abstractions and how many libraries you really have in your code base and how heavily you're actually using HOCs, because in some places, you may only be using one of them, but it still technically has some of these problems. But when HOCs were first introduced, and probably still, people were HOC happy because they said, we want utilities for all these different things, so we're going to chain these things together, and we're going to attach this different functionality to a component. And so the way that I thought of to describe this is it became like a long dark tunnel that was difficult to tap into. And I'll show what that looks like in a second here. So this is an example of chaining more than one HOC together. So I have my underlying UI component. I'm attaching a media query listener to it. I'm attaching with hover, and then these are just arbitrary examples. You probably wouldn't use these together, but there's a with battery that reads a battery level from a mobile device. And so the first thing to notice is you've got some nasty nesting going on here. So it's a little difficult sometimes to keep track of what's going on if you've got a large component with these things chained onto it. And then as a result, you can also kind of lose track of, again, what's going on here, and the UI component is not as obvious, although it's defined up here. But now, none of these HOCs actually take runtime props, but one of the issues with HOCs was that it was difficult to pass them runtime props if you needed to do so. So I just sort of made up an example here and said, what if we, in addition to this thing maintaining state in and of itself, what if we wanted to elevate that state, or what if we also wanted to attach a listener to it called on battery level change or something like that? That's a long name, but just an example. And how would we pass that to this? So we could pass it statically when you define this component. We could pass something once and forever, but there's no way to assign that dynamically without passing it to the top level component. And so I'll show you what that looks like. So here you have an example of these several different things chained together. I'm addressing this top level component, and I had to pass my on battery change, which addresses this one, I had to pass some other HOC prop and then some other prop that my UI uses, and they shared the same namespace. So kind of a cheesy thing I have here. It says, here's one end of the tunnel, make sure all passengers are on board before we go through. So coming out the other end, glad everyone made it. You have the same problem. You have this shared namespace that's mixed. Does this remind us of Mixins at all? It's not as bad, but it has, you know, some similar characteristics. So out the other end, you got your hover props, you got your media query prop, and you have your battery level prop. And then this is just this has nothing to do with anything else in this file, but this is just a random example that I pulled online from someone that was using a library called Recompose. And I think, to me, Recompose was a bit of a smell for this problem, because it essentially invented a programming language to solve this problem of all these components that you were foisting on top of your underlying UI component. So there were different utilities that would allow you to get around some of these problems. So for example, there was compose. So you don't have to deal with nesting. You can look at these a little bit more flatly. And then there was map props, which allowed you to manipulate the props midstream. So this became applicable when one of your HOCs would have a different signature than another one, and so you would be able to change the props so that from one to the other, you'd inject this in between two of them. So obviously that can get a little ugly. So you had an indirection issue, which I talked about. It's hard to know where things came from and what you were addressing. Another way that I thought of to put it is it was kind of like composing multiple JavaScript functions, but they were all forced to share the same method signature. Even if it is an object, it was kind of an arbitrary object that could have all sorts of things hitching a ride. And so as a result, you had to blindly proxy unknown props from one to the next. And there were some issues. I'll gloss over this because we don't do this as much in more modern functional React, but if you had statics on a class, static properties, and you were trying to access them from the underlying component, or another use case is if you were trying to test that underlying component, you would have to export that independently so you could actually address it from the outside. And then, you know, the problem is magnified by if we're using third-party HOCs and we don't have as much control over how they handle some of these issues. Other issues that I already talked about was the composition was static, and we had problems with class name debugging. So there must be a better way. And so before I get into the next two technologies, I'm just stepping back and asking a couple more fundamental questions. And sorry, you can see my slide ahead of time and you can see where I'm going, but the first question is, how do we do abstractions in vanilla JavaScript? The answer is we compose classes and functions. So we have function A that takes in some inputs and returns some outputs. Then we have function B that does the same thing. And then we can take the output from A, we can tie it into B, and it's a little bit clearer how we can see these things fit together. Increasingly, moving toward the functional side of things is becoming more popular. I know in the React community, and I think in JavaScript in general. I've got friends that use Svelte and talk about the same sort of thing, and other frameworks. I think Angular uses more classes still, but I'm not a huge Angular guy. But there's a lot of people moving in that direction. So the second question is, why do we need these special constructs anyway? And that's what I kind of addressed that in one of my earlier slides. We need to be able to take advantage of React features. So this would be the component lifecycle, statefulness, encapsulating our imperative code in our declarative components, and so on. Now I wanted to stop for a second because I just glossed over another topic, imperative versus declarative. Again, most of you probably already know this if you use any of these frameworks, but the difference between the two would be imperative, it basically says go forth and do such and such. So if I have a button and I grab it through jQuery with an ID, and I say my ID, whoops, .css. It's been ages since I've done this, so I don't even remember if that's the right function, but we'll say color or background color is red. So this would be an imperative. Go and do this thing. Go make yourself this thing. A declarative would be in a React component to have a component that responds to state. So you would have, or props. So you would have, what type of button is this, right? Type. So if it's success, I'll just pseudocode here. So if it's success, then return, then make it green. Return something that's green. So this would be a button color equals green, except I'm pseudocoding. But you get the idea. So the idea is that it returns some rendered DOM that reacts to props that are passed to it or to state somewhere. So when the state changes, it re-renders this and it shows the updated DOM. So that's important because we're going to see a little bit later how some of these other things that we're talking about can become declarative. All right, so this is a functional programming example because we're talking about low-level functional programming. Now ignore the fact that I mentioned pure function here because I forgot to take that out, but basic ingredients to a function, you have inputs and outputs, pretty basic stuff. A pure function is something that has no side effects, and we should try to make our code that way as much as possible, but in the React world, obviously, there's other things going on. You could hook into a Redux store or something like that, and you're interfacing with the outside world a little bit more. So that will vary. But here's an example of a basic function like I talked about a minute ago. So we have a get even, which when you call it with an array of numbers, it will return only the ones that are even numbers. So pretty easy to understand. I've got some inputs and I get some outputs, and that's that. Next example, let's get the sum or add those together. Again, I take in an array of inputs, I get some outputs. So the nice thing now is I can compose these together almost like a recipe, and I can see exactly what I'm dealing with. So here's a composition. I can take in some numbers, and I can say I want to get only the even ones, return those, and then get the sum of those. So the example here would be if I pass in these numbers, it's going to return the sum of 2 and 4, which are the even numbers. So the question is, when we're looking at mixins and HOCs, they don't exactly behave that way, so how can React be a little bit more like that internally? So the next pattern that we'll look at is render props. So what are those? They became a highly popular pattern in the React community as an alternative to HOCs. Examples, probably the first example I would think of this is the new-ish React Context API. It's been out for a little while, but they had one for a long time that was experimental. Then they finally came out with what they thought context should be. I don't know if part of the delay of that was maybe some of the things we're talking about, that they were looking for a way to to express that better. But there are lots of other things out there that use render props. There's a whole website that lists a bunch of things. And they were called this because they're defined by passing a render function or a component to the render prop or any other prop. And I'll show what this looks like. All right, so here you have a component that's using render prop wrappers, if you want to call them that. So there's a couple of them that I've chained together, just like we chained together our HOCs. This one is a context consumer. So I mentioned I was going to talk about context. So the way that this would work, just briefly, is you would have a provider somewhere up the component tree that you would pass a value to, and it provided that value to the context, which was basically all the components that were rendered underneath your parent. And this was a way to kind of get around the problem of prop drilling, which is passing props through each intermediary component. But that's a bit of a sidebar. But the consumer received that value, and this right here is actually a render prop, which is a little bit unclear because this is actually the children prop. So I'll show you the other end of that. I'll show you what the actual render prop wrapper looks like. But this is basically using the children prop, and it's calling children as a function, and then whatever is returned from that function, that gets rendered to the DOM. So here we have another one. I reworked the with hover HOC as a with hover render prop wrapper. And this has clear inputs. Now this is a bogus input. It doesn't really need this, but I was trying to show an example here. So I could pass a prop to it, and immediately we've already solved one of the problems with HOCs because we can pass runtime props. And then we get clear outputs. Now already here there's a problem because this is kind of confusing React paradigms. Technically, the output of a component when it renders is rendered UI, right? So when we call these our outputs, which is we're really hacking something together here so that we can then pass these down to something that's underneath. So it's using a tool that wasn't really designed for that, but it works, and it had some advantages. So under the hood, you have this wrapped. Oop, I actually misnamed it. It should be just with hover. So you have this this with hover component. You pass it children, which is actually the function we saw a moment ago. So here's the children, and it calls the children with these outputs is what I'm going to call them. That's what comes out this side. And then whatever results from that function is what gets rendered to the DOM. All right, so this had some advantages. It was more composable in a non-linear fashion. Linear meaning that tunnel that we talked about. The prop namespace was shared within the render statement, but it's really no different than any other JavaScript closure, or you know, like within a JavaScript method, you have this namespace that doesn't break out into the global namespace. It's contained or encapsulated within that namespace, but it's obvious where things are coming from, and that's what we saw a second ago. So the namespace that's established is within this closure, but it's obvious that we have a value here, we have some other things here, and it's obvious which one they come from. So no more blindly passing through or having to proxy unknown props. And it was also easy to assign runtime props. But there were still issues. So the first one is the nesting is actually worse, in my opinion. You start stringing these together and this can get really ugly. I don't think any developer really likes ultra tabs. So that's an issue. It was not the simplest of syntaxes still. And some people pointed out there were potential performance problems, but this was usually not an issue except in large data intensive apps with large data sets. I did run into this at quiet time to some degree because we were streaming live data every second and lots of it. And so as a result, we had to optimize to some degree for re-renders. But again, most of the time you're not going to run into this issue, and it's overcome. It's something you can overcome. As I said, there's still a problem with the paradigm because this is really designed for React components are really designed for UI. So after, I forget how many years I said in the intro or how many years it was, but 5-6 years or whatever since Mixins went away, finally the React team came out with something that I think solves all of these problems, and that was React hooks. So what are they? Hooks are functions that let you hook into React state and lifecycle features from function components. I didn't put this in quotes, but this is from the React website. perhaps more importantly, they allow us to add React features without having to deal in the UI. So this is non-UI functionality, logic, side effects, state management, etc. So this is a much more complex example than some of the other ones that I did, and it's maybe somewhat useless, but I'm stringing together several different things here, and the thing that I'm trying to show is that it's a lot more concise and a lot easier to reason about. So I have a hover, I have a use counter, which counts from 5 to 10 at varying increments. It's on a timer. So every 200 milliseconds, it's incrementing by 1/100th. And then if I hit plus, it increments by a whole number. And then if it reaches 10, it cycles back to 5 because I'm using a range. That's something that I have baked into my counter. So as you can see, this is much more functional. It looks a lot more like our simple functional examples from earlier. So you can clearly see what your outputs are. Here you can clearly see what your inputs are and what your outputs are. And this is all runtime. So this is when the component renders. You can pass these things at runtime. And then you can compose them together. So here I'm composing my increment function with a use interval hook. Now let me back up for a second for anybody that's not familiar with hooks and just explain that the convention is that if it starts with use, lowercase, that's typically a hook. That's the naming convention. So all of these are hooks. This is use hover, use counter, use context, use interval. Let's see if I missed anything here. So again, there's a lot of functionality packed in there, and it's easy to see what's going on. All right, so to give a little bit more practical, hands-on examples here, I grabbed a refactor or constructed a refactor example. This is pulled out of a code base and then redacted and modified and so on. So this is a user search form that lets you search for a user in an API or in a database. And as you can see, there's a bunch of stuff going on here. It's 226 lines long, which is certainly not as bad as I've seen, but it is kind of long. And there's a lot of logic at the top here. There's event listeners, there's state, there's API calls going on. So there's a bunch of different things happening here. So I started to, I wanted to put together an example. So I started to think about what are some of the things we could pull out of here, use some hooks, maybe make some libraries. Maybe not everything has to be a library, but what are the pieces we can start to pull out? So the first thing that I had to do to kind of support later steps was the API uses snake case for its variables, whereas JavaScript conventions typically prefer camel case. So I went and switched a lot of that over, and at the same time I tried to minimize the amount of times that we're referring to all these. So I've got a default form data constant that's frozen, so it can't be mutated. And so I've done a little bit of tweaking here. The second step is that we have a API library or abstraction that we created. This is called my API. And so right off the bat, there's some boilerplate that happens throughout the website. There's some headers that get passed most times that we do an API call. So that gets pulled out into the library. And I'll talk a little bit more about the layers of that library in a little bit later. But that allows us to slim this down a little bit. Next thing that we do is we switch it to a functional component. So again, the React community is increasingly going in this direction. Before we had a class, now we have a function, which is the only way that hooks can work. So now I have a bunch of use state hooks here. Now, I wouldn't have to do 5 different use state hooks. I could put them all in one object, but that's just what I chose to do in this particular instance. And so I'm transforming everything to use those. All right, next step. This one's interesting because this one talks a little bit about, or this one addresses the differences that we talked about between declarative and imperative programming. And the difference here is subtle because the API call that we're going to make is a post, and it only happens when you submit the form. And so, at least the way that I've done it here, it is an imperative, but we are trying to express some of it in a declarative fashion. So, again, the difference is subtle, but look at this. So we basically declare this right out of the gate, and then we say we don't want this to actually fire right away. Now, if this was a GET request and the component relied on that data, we might fire it off immediately. It would be a side effect. It would be on component mount, essentially fire this off. But in this case, we don't want to do that. So we're going to pass a lazy equals true. It's going to be a lazy request. And then down here, when we're actually doing the search, which is the imperative, instead of waiting for this thing, so we have an await here, and instead of waiting for this thing and kind of having this process baked into the component, which involved setting an is loading state and some other things and error handling and all of that, and then doing some things to react when the API call actually returns, I want to bake that into my API library. So that's what this hook allows me to do. So as you can see, I'm still firing off an API call, but I don't actually wait for it to come back. I fire it off, and then I wait for the state to update that's baked into this hook. And when it updates, then my component reacts to that and returns things like the status. So we have status.hasFinished. We have status.isLoading, and we have some other things going on here. All right, so next piece, and I'm going to gloss over this because I don't want to introduce too many concepts, but one of my other favorite pieces to abstract is form behavior. And this was doing a lot of form stuff that is useful elsewhere in the code base. So I just I hacked together a quick and dirty context form. And what that is I have a form component. You notice that this is now a capital letter, so this is my own custom component. This returns the form DOM element, but it also has a context provider built into it. And then I have these inputs that basically subscribe to updates to that, or I should say affect or subscribe to updates to that content. So they can actually manipulate that context data. And then receive it when it does update. So by doing that, I was able to pull a lot of this stuff out, and that was probably my biggest piece. And then I thought, well, all that we've done so far has been hooks and logic and functionality, and let's do something UI related. So I said, what's a logical piece? What's a chunk or a unit of this that we could reason about independently? And so I looked at all these containers. I'm not sure why we have so many, but it must be a complex display of some sort. And so I put all these together as a unit and called it a card. So I think that's the last piece here. And then if we actually open up, I can get my my controls to go away here. If we open up this, we can see that it's a lot more concise. And easier to reason about. So we can tell exactly what's going on here. This is a user search form. It has some inputs, and there's not a whole lot else going on here. And we went from 220 some lines to 81. So that was a pretty good gain in manageability, I would say. All right, so now I wanted to dive a little bit into what we did with this API. And I'm just going to check and see how I'm doing on time here. All right, so you notice that I used a use API hook somewhere here. Use my API. But there were some, so we started looking at there were existing libraries out there that did this. There was use Axios, and there were some various hooks that people had created. But we decided we wanted to have something that we owned that we could do some specific things with it and make it a little bit more flexible than what was already out there. So we created several building blocks, and these really came as a result of good team collaboration. And I would highly recommend, if you don't work at an enterprise company, spending some time at a a company with some decent teams that you can talk these things through with, because when you do all the give and take and you get away, you get over your ego and learn to collaborate a little bit better. Some of these things bubble to the surface. So as we talked about this, we said, there's dozens of different things that we could do with this thing, and there's different customizations that we could do with it, and so on. So here's some of the basic building blocks that we have. We have a use promise that underlies our use API. What this is that it is a hook that manages the life cycle of an arbitrary promise. So I'll give an example here. Without knowing what this is yet, I'm going to say equals use promise, and then I'm going to pass it a promise. This could be anything. So I'm going to use as an example just the vanilla Axios. I'll say axios.get. Axios is an API library, or we could use fetch. I believe fetch returns promises. So we pass it a URL. And whatever this promise is, actually this is a promise getter because we don't want it to fire right away. So whatever that is, we do a use promise, and then we have it react to some things. So let's say we declare some state here. Whatever this variable is, set a equals use state. And this would take a default, but I'm going to leave that out. So if I add a to this array, this is under the hood. This is using the React use effect hook, which deals with side effects. So what this says is I want to fire this thing off or update. In the case of use effect, it could be a lot of different things that you'd be doing with this, but I want to fire this request off initially and when a changes. That's the idea. So if in my component, if I have an on click somewhere equals set a something new, that will cause this to refire, to refresh the API request or hit the server again. So this was a building block. We wanted to be able to use this a little bit more flexibly and not be tied to our specific API implementation. So that's one building block. Then we started talking about some of the other features we could inject into this. I'm kind of moving down a little bit here, but we have error handling, we have request and response transforms, so you could do data normalization and denormalization when the data is sent back and forth to the API. You could do some state management because what happens if you call a particular API endpoint, get some data, and then you subscribe to that data. So if it changes somewhere else in your app, your component will re-render. You want to have some state management functionality there. And the fetcher itself is actually, I'll show how that works, but the fetcher itself is actually a dependency that gets injected. So what's the fetcher? The fetcher is essentially, if you want to use Axios as an example, it's the thing that makes the API call that returns the promise. So let's blow this away and let's give an example of a fetcher. The fetcher in our case with that component that I was refactoring was my API. So I could do my API.get and give it a URL. And this will return a promise. So I could pass this into use promise, and I could do it that way. But essentially, what we did was, first of all, we had a factory that created these fetchers. So my API was create API, or sorry, it was create fetcher. and we would pass some options to it. Now already here we can inject some things. We can say, let's give it a root URL. That's a configuration option that we allow. So let's say myroot.com. So now when I call myAPI.get, it's going to call out to myroot.com/something.
Hey, Jonathan, sorry
Yep,
to interrupt. Can we just increase the zoom size of this editor?
Oh, yes. Thank you.
Yeah.
Wish I had realized that sooner.
Yep, this is fine. Yeah.
All right. And I do only have a few minutes left here, so I'm going to wind down. But so the next piece was, how do we put this into a hook? This is, like I said, this is more imperative. So how do we put this into a hook? We created a factory for that. So we said use my API equals create API hook, and we pass it the fetcher. Or this could just be, well, yeah, that's, and then there are some other things we could put into here, like state, I forget what I called this, state hook or something like that. So this would be, let's say we use selector, which is Redux's selector hook. So we can basically inject these different things into our hook. And now that I've created this typically would happen once for whatever API that you're addressing remotely. So whatever's at myroot.com, you would create this thing at the top of your app somewhere. And then wherever in your app you wanted to use that, you would say, use my API. And it would basically get this behavior out of the box. So using some of these building blocks, I really wanted to get across that this is a model, I think, for building things up from the ground level. And the idea is that, you know, if you don't like your top level, if I don't like my use my API, I can always go to whatever's underlying and use that instead. So this is something that you can pull apart, and it's a little bit more flexible. I've personally had a lot of pain with finding a library somewhere, and this actually happened with this presentation itself. So what I'm using here for this presentation is called Spectacle, and I used Spectacle, and then I used a plugin for dealing with these code demos that I was showing here a second ago. And there was another one that I found that did some other cool things with code, but the problem with some of these is that they don't break down. So in order to actually make some of these things work with each other, you would have to basically fork the project and customize it yourself. So that's one of the things we tried to get around by thinking through our libraries a lot more carefully. But as you can see, hooks were extremely useful in this, and so I hope that anybody that hasn't tried them already will get on board and play around with them. This is a quick demo of the use promise. So you have timer, this is a promisified timer that I created, and if I switch it to API call, now I'm going to get some data coming back from the API. Must be disconnect. Oh, there you go. So I get a hello world. I can restart it, which runs that start command. I can do something that's not supposed to be allowable with promises, and I can actually cancel it. This is something that Axios, it actually was a JavaScript proposal at one point to allow cancelable promises, and it was never accepted. Axios uses essentially the technology that was in the proposal and enables that as a feature. But we pulled it out, we made it our own, and so you could cancel my timer here just as easily. So that's it. Anybody that's familiar with the Mandalorian Disney Plus Star Wars show, I thought this meme was really funny because there's this character that at random times that don't really make any sense, he says, "I have spoken." So I have spoken. Do you have any questions in response?
So I think we have two questions on the Slido portal.
Yep. It actually didn't occur to me that people would ask questions there, but that's, thank you for watching that.
Yeah. So like, it's like the first question is like, can we assume hooks as similar to event handlers?
Can we, what is it again?
Can we assume hooks as similar to event handlers?
Let's see. So, not exactly. I'm not sure if I 100% understand the question, but
yeah,
so,
I just sent it to you on the chat.
Yeah. Let me look here. So I actually in my refactor I showed an event handler coming from a click, or at least I thought I did, but I might have glossed over it. Well, okay, yeah, I think I understand what you're saying. So, so a hook can really be anything, and it could be used to subscribe to events. So, you know, a good example would be Axios's, I'm sorry, Redux's use selector. So they have my data equals use selector, and so you have your Redux store. And you pass it a selector, so I'll call the store C for cache, or I guess I could say S store. That's the convention, I guess. And then I could return just a specific piece of that. So obviously behind this you have some functionality that Redux put together to listen to updates to that store. So that would be one type of event. As far as JavaScript events are concerned, I'm thinking more of on-click events and so on, which is not directly related. But if anybody wants to add anything, feel free on that.
Yep, sure.
Anything else? Let's see, I'm looking at.
So the other question is like, is there any resources you can share it to the group, like if they want to have or get more understanding on the abstraction patterns which we discussed today?
That's a really good question. I could probably put out something for that. So as far as the Mixins, HOCs, render props, and so on, and also hooks, I would recommend, for most of those, I'd recommend looking at the React documentation. It's really good and concise, and explains several of those, including things that aren't official React. I haven't looked lately, but I believe that that they have things on render props and HOCs. Sorry, my presentation thing is getting in the way here, but HOCs or render props, I believe, is a good example. So probably one of the, reactjs.org. So I would recommend that. For some of the stuff that I talked about in terms of building blocks for our API library, I could put together some examples for that. Maybe share a slide or two. Maybe turn this into a blog post at some point if people are interested in that.
Yep, sure.
And Beam, by the way, Beam Dental does have a blog. So like I said, that might be a good place to put some of this for future consumption.
Yeah, that works out, Jonathan.
All right, anything else?
So any other questions we have from Zoom attendees? So I don't think we have any other questions, Jonathan.
Okay.
Thank you for speaking today with the group, and
Yeah.
thank you for spending time with us and sharing all the details with us.
Yeah, I enjoyed it. I especially would love anybody that's on the line. Hopefully I get to meet you at a Columbus meetup somewhere, or maybe at the next JS and Friends conference or something. Love the in-person ones, but like I said, I hope that this benefited people. I may send out a survey or something just to see who was listening. So.
Yep, sure.